So now we are going to start with the next chapter, that is biomolecules. In biomolecules we are concerned with the molecules related to life. That is, we have and molecules which are present in our body. That is, our body is made up of different types of molecules. For example, carbohydrate, then proteins, amino acids, then vitamins, hormones, then comes nucleic acids. Now we are going to study about these molecules. First we will take carbohydrate. See, carbohydrates are defined as or was once defined as hydrates of carbon. Hydrates of carbon means we can write these molecules as suppose C6H12O6. We can write it as C6H2O 6 steps. That is the hydrate of carbon. Now, so here we are going to define this carbohydrate. So it was once defined as the hydrates of carbon. But ethanoic acid, you see ethanoic acid CH3COOH, that is C2H4OH, which is written as C2H2O twice. It is a hydrate of carbon, but it is not a carbohydrate. This is not a carbohydrate. Ethanoic acid is not at all a carbohydrate. So that definition we could use. And another example, rannose, that is C6H12O5. We cannot write it as a hydrate of carbon, but it is a carbohydrate. So that definition, carbohydrate, that is hydrates of carbon, it was then removed and a new definition was given. The new definition given is carbohydrates are polyhydroxyaldehydes or ketones. Carbohydrates are polyhydroxyaldehydes or ketones. Polyhydroxyaldehydes or ketones. Aldehydes or ketones, or molecules which on hydrolysis gives this polyhydroxyaldehydes or ketones. So carbohydrates are either polyhydroxyaldehydes or ketones, or the molecules which on hydrolysis gives this polyhydroxyaldehydes or ketones. Okay. Now we can classify carbohydrates are also called saccharides. That means in Greek it means sugar. Now carbohydrates are classified first into, depends on the units present, we can classify them into monosaccharides. Monosaccharides are compounds or molecules which contain or which are polyhydroxyaldehydes or ketones. For example, glucose, fructose, they are monosaccharides. Then comes the carbohydrates which on hydrolysis will give you 2 to 9 monosaccharide units. 2 to 9 monosaccharide units will be obtained on hydrolysis of these compounds, and they are called oligosaccharides. These are called oligosaccharides. So oligosaccharides are those which on hydrolysis will give you 2 to 9 monosaccharide units. Then we have carbohydrates which on hydrolysis will give you more than 9 monosaccharides. They are called polysaccharides. So polysaccharides are molecules which on hydrolysis will give you more than 9 monosaccharide units. So we have monosaccharides, then oligosaccharides which contain or which on hydrolysis will give you 2 to 9 monosaccharide units, and we have polysaccharides which on hydrolysis will give you more than 9 monosaccharide units. Here polysaccharides examples, we have cellulose, starch, etc. For starch, all these are polysaccharides. We have oligosaccharides, we have sucrose, then maltose, lactose, etc., which are all disaccharides. Oligosaccharides we can again classify them into disaccharide, trisaccharide, etc. depending on the number of monosaccharide units present. So we have classification into monosaccharide, then disaccharide or oligosaccharides or polysaccharides, and now look, this carbohydrates are again classified them into reducing sugars and non-reducing sugars. Reducing sugars are those which give filling solution test or tolerance reagent test, or those which can reduce filling solution and tolerance reagent. They are called reducing sugars. Reducing sugars are those which can reduce. Reducing sugars. Those which can reduce filling solution and tolerance reagents. We have studied in aldehydes and ketones. Aldehydes are or they can reduce the filling solution and tolerance reagent. So such sugars are called reducing sugars, and those which cannot are called non-reducing sugars. So reducing sugars and non-reducing sugars are that all monosaccharide units are, or all monosaccharide molecules are reducing sugars. Okay, so this is another classification of carbohydrates. And now we will go to the simplest or the monosaccharide, glucose. Glucose. After the determination of empirical and molecular formula, we have come to the conclusion that glucose contain this, or the molecular formula of glucose is C6H12O6. You know the steps in the elucidation of the molecular formula and empirical formula: percentage composition, then determination of empirical formula, then determination of molecular mass, then determination of molecular formula. That we have already studied. So glucose has the molecular formula C6H12O6. Now glucose, how is it manufactured or prepared? It is prepared by the hydrolysis of sucrose. It can be prepared by the hydrolysis of sucrose. Sucrose is C12H22O11, which on hydrolysis with the dilute acid, you can hydrolyze it into C6H12O6, that is glucose, and you will get fructose, C6H12O6, that is fructose. So glucose and fructose you will get. Okay, or you can even hydrolyze starch, that is C6H12O6 N times. So polysaccharide, you will get on acid hydrolysis when it is heated with a dilute sulfuric acid, you will get glucose, C6H12O6 N times. So by hydrolysis of either sucrose or cane sugar, you will get glucose and fructose, or by the hydrolysis of this polysaccharide, that is starch, with the dilute sulfuric acid, you will get glucose. So this is one method for the, or these are the methods for the preparation of glucose. Now how we elucidate the structure? We will have to study certain reactions of glucose, reactions given by glucose. The first one is reaction with HL. Reaction with the HL. See, when glucose is heated with the continuously with the hydrogen iodide, you will get N-hexane, C6H12O6, when it is heated with the HL. You will get N-hexane. What is N-hexane? It's a straight chain of 6 carbon atoms. CH2, CH3. You will get a chain of 6 carbon atoms. So you will get N-hexane, showing the presence of a straight chain of 6 carbon atoms. So glucose has a straight chain of 6 carbon atoms. This is N-hexane, normal hexane. So this is the proof for the presence of a straight chain of 6 carbon atoms in glucose. When it is heated with the hydrogen iodide, you will get N-hexane. Now, when glucose is treated with the hydroxylamine, you will get oxide and when it is treated with a hydrogen cyanide, you will get cyanhydrin. These two reactions are given by carbonyl compounds. So showing that this glucose contains a carbonyl group, CHOH, CH2OH. See, when this is treated with a hydrogen cyanide, നമ്മൾ പഠിച്ചാണ് ഹൈഡ്രജൻ സയനൈഡ് എങ്ങനെയാണ് C double bond O H. ഇത് ഇങ്ങോട്ടേക്ക് ഷിഫ്റ്റ് ചെയ്യും. അപ്പോൾ O മൈനസ് ആവും. അവിടെ ആര് വന്ന് ആഡ് ചെയ്യും? H1 ആഡ് ചെയ്യും. Cn മൈനസ് വന്ന് കാർബണിലേക്ക് ആഡ് ചെയ്യും. സോ വാട്ട് വിൽ യു ഗെറ്റ്? CH OH Cn cyanhydrin you will get. So glucose will react with the hydrogen cyanide to give cyanhydrin, and with the hydroxylamine. What is hydroxylamine? NH2OH. Hydroxylamine. Same reaction. എന്ത് പറ്റും? ഈ രണ്ട് ഹൈഡ്രജനും ഈ ഓക്സിജനും കൂടെ എന്ത് ചെയ്യും? വാട്ടർ ആയിട്ട് എലിമിനേറ്റ് ചെയ്യും. So what will you get? CH double bond NOH, isn't it? Then CHOH 4 times CH2OH. So glucose when treated with the hydrogen cyanide will give cyanhydrin, and when it is treated with the hydroxylamine it will give oxime, showing the presence of a carbonyl group. So glucose contains a straight chain of 6 carbon atom, and it contains a carbonyl group. Now when glucose is oxidized with a mild oxidizing agent like a bromine water, when it is oxidized with a mild oxidizing agent like a bromine water, you will get a monocarboxylic acid with the same number of carbon atoms. And we know that out of aldehydes and ketones, only aldehydes can be easily oxidized, isn't it? So bromine water, which is a weak oxidizing agent, it can oxidize only aldehyde group to carboxylic acid. So you will get a monocarboxylic acid, CHOH 4 times CH2OH. Okay, so this acid is gluconic acid. So aldehydes, only aldehydes out of the carbonyl compounds, only aldehydes can be oxidized to carboxylic acids by weak oxidizing agents, showing the presence of a weak oxidizing agent, bromine water. Next is when, so out of the carbonyl group, which carbonyl group is present in glucose? It is aldehyde. Now when glucose is treated with the acetic anhydride, you will get a pentaacetyl derivative showing the presence of 5 OH groups. But glucose molecule is highly stable, and I told you in a carbon atom if more than 1 OH group comes the molecule will become unstable, isn't it? So that means this 5 OH group in glucose, they are on different carbon atoms. Okay, so glucose CHOH 4 times and CH2OH. When this is treated with the acetic anhydride CH3CO twice O, you get a pentaacetyl derivative CHO CO CH3 4 times CH2O CO CH3. You got a pentaacetyl derivative showing the presence of 5 OH group, and these 5 OH groups are on different carbon atoms. These 5 OH groups are on different carbon atoms. Okay, so now we have the proof for the straight chain of 6 carbon atom. We have the proof for the presence of carbonyl group. We have the proof for the aldehyde group, and now we have the proof for the presence of 5 OH group on different carbon atoms. Now glucose, when it is oxidized with concentrated nitric acid, which is a strong oxidizing agent, you will get a dicarboxylic acid. Glucose, when it is oxidized with a concentrated nitric acid, which is a strong oxidizing agent, you will get a dicarboxylic acid which contains same number of carbon atoms, showing the presence of a primary alcoholic group, COOH, CHOH 4 times, and COOH. This is saccharic acid. So glucose on oxidation with the saccharic acid, with the concentrated nitric acid, gives a dicarboxylic acid, saccharic acid with the same number of carbon atoms, showing the presence of a primary alcoholic group. So glucose has a straight chain of 6 carbon atoms. It contains a carbonyl group. Out of the carbonyl group, the aldehyde group is there. Then there are 5 OH groups on different carbon atoms. Then one of that OH group is a primary alcoholic group. So with all these proofs, scientists start to give the structure of glucose. How the structure of glucose is given? It is an aldehyde. So CHO group is there. CHO, then CHOH 4 times and CH2OH. This was the structure given for glucose. COH, H, CH, OH, OH, H, COH, H, then CH2OH. This is the structure given for glucose. This is glucose. Now here instead of CHO, if it is COH group, it is gluconic acid, COH, H, HOH, H, CH2OH. This is gluconic acid, then gluconic acid, then which is saccharic acid. This COH group, CH2OH is also COH group, then it is saccharic acid. So this is the structure proposed for glucose. Now a scientist called Fischer, he gave a Fischer projection formula in which the carbon atoms are represented by a junction of a vertical and a horizontal line. The vertical line, at the top of the vertical line, the most oxidized atom, and the lowest end, the less oxidized atom. Then the other atoms are shown as like this. Horizontal lines, and the junction will be carbon atoms. Here OH, H, H, OH, H, OH, H, OH. This is the Fischer projection formula proposed. Now you see there are 4 carbon atoms which are asymmetric. Asymmetric means 4 different groups are attached. Therefore 2 raised to 4, I told you that if n asymmetric centers are there, 2 raised to n optically active isomers are possible. Here there are 4 asymmetric carbon atoms. This carbon atom with the one end CHO, this here OH, here H, here this which group. So 4 different asymmetric carbon atoms are there. So 2 raised to 4. That means 16 optically active isomers are possible for glucose. So out of that, some will be plus, some will be minus, and then enantiomers will be there, and out of that one will be D, and other D and L notations will be there. Now in glucose you might have seen the capital D and capital L notation. What is this? Capital D and capital L notation. It is based on the glyceraldehyde. Glyceraldehyde is CHO, OH, H, CH2OH. Only one asymmetric carbon atom is there. And if OH group is on the right, it is D, and if OH group is on the left, it is L, or it is plus glyceraldehyde, and if OH is on the left, it is L glyceraldehyde or minus glyceraldehyde. Now based on this, glucose is also given the notation D and L. In plus glyceraldehyde, OH group is on the right. In a glucose, if the last symmetric carbon atom, if the OH group is on the right, it is called D-glucose, and if it is on the L, it is called L-glucose. Okay, this is the D and L notation. It has nothing to do with the dextrorotatory or levorotatory. Okay, so this is about the straight chain structure of glucose.